Hi everybody, welcome to the SSW user group, and thanks Adam for the wonderful tech news. So before we get started, I've got a cool SSW rewards app here. You can install it by scanning that QR code and you get some points just for installing it. At the end of the talk today, there's another QR code, some more points that you can use to claim some of these cool prizes. So there's a Xiaomi band, there's some cool digital keep cups, and I think we've got a few more things coming, which is pretty cool. So grab that QR code now, and we will see who gets to win some prizes at the end. Okay, so tonight's talk is called Flexing Your Biceps with Azure. It's all about having a lot of fun, just like this dude jumping out of off a waterfall. So yeah, it looks like he's having fun and showing off his guns as well. So let's start with a rough definition of infrastructure as code. So it's all about automating our resource provisioning, right? And no pun intended, was triggered by the success of CI/CD processes. Just like how we automatically build and deploy our code, why not provision our resources in the same way? And this automation, just like most automation, helps us to reduce the cost, the risk, and increase the speed of getting things out the door. Now, cloud infrastructure these days are actually getting a lot more complicated. A lot more services out there and a lot more things that we can actually do in the cloud. And we're going to find a lot of JSON, YAML, and XML files literally everywhere, which, for me, sometimes it's a bit hard to deal with. You don't feel too productive using data type languages or markup languages to do something programmatic. I like to keep things simple, so the KISS principle applies. Okay, so just a little bit about myself. My name is William Liebenberg. I'm a solution architect here at SSW Melbourne. You can find me on Twitter. I've also got a blog site called Azure Gems. And if you want to sort of engage a bit more formally, you can find me on LinkedIn. Now, I started programming when I was quite young, I think about 5-6 years old. I wrote my first little app or program on a Spectrum Video 328 using the basic language. And it looked kind of like this. Everything was loaded and saved onto tapes and cartridges. And everything was also beige back then. So luckily we've moved on from then. Then started doing some 3D game dev or development with game technologies, C and C++ since 1999. Moved over to .NET version 2 after wasn't sure about version 1, sort of the brand new technology, and wasn't too keen on it. But V2 definitely changed my mind. I've been using .NET pretty much every day since. I've also started using Azure around 2014, doing a lot of cloud work, and this is pretty much my daily stack. So anything Azure and .NET, Bicep functions, etc. And also now I'm going to add Bicep to that list. So let's have a look at what we can do with Azure Bicep. So I'll go and cover what it is. We'll look at how Bicep compares to the other options out there. So we've got Terraform and Pulumi, the very popular ones. And I'll also show you how to use Bicep in the right way, or the best way, in my opinion. We're going to cover the really cool feature called module registries. And I've got lots of demos to show you of how all this runs and what we can do with it. But first, we have the Azure Resource Manager, ARM. And as you can see in this diagram, whether it's the Azure portal, the Azure PowerShell modules, or the CLI, any other REST clients, they make use of the SDKs or the ARM API directly to go in and provision these resources. That's the only way you can get into Azure to say, give me a storage account, give me a web app, etc. So this is the basic picture of what ARM is. Now, Bicep is a new language. It's the DSL, sort of the domain-specific language, and it helps us to simplify the templates that we write to provision our resources. Back in the day, or just the other day, we've basically been using JSON, ARM JSON to write our templates and to sort of declare what we want our infrastructure to look like in the cloud. But with the simplified Bicep, it's also more modular. It's easier for us to deploy a lot more resources in different resource groups and subscriptions at the same time using nested deployments in the background. It does it all for us. We don't have to do that. That was quite hard to do with ARM JSON. And also, Bicep lets us reuse our code a lot more than ARM JSON. It's a lot easier, especially when we look at the module registries a little bit later. Now, as an example, here is a basic bicep file that declares a storage account. You can see, just like most programs, we have an input parameter. We want to give a name as of the type string. We have then a declaration of the resource type with a whole bunch of properties. But in the end, we can also then output. Each of these bicep files can output values that we can reuse in our DevOps pipeline, or we can wire it into the inputs of another bicep file. So I'll show you how to do that. So it's pretty cool. Now that same storage account bicep file on the left, if we compile that to the JSON equivalent, you can see on the right hand side, it's a bit small. It'll sort of zoom out to fit everything in, but you can already see that the bicep file, that version is a lot shorter than the JSON file. So all the weird programming syntactic sugar that was added to JSON to get these things working, it's just so much nicer in Bicep. So you can actually save a lot of keystrokes, which is really nice. And like I've mentioned, there's two types of ARM templates. There's the traditional JSON templates and now Bicep. But both of them underneath, they translate into the REST calls to the Azure Resource Manager so that it can go ahead and provision the stuff that we want. So let's say we start off with a file, main.bicep. It's got all the stuff we want in there. And under the covers, well, before we do that, we actually have to create a deployment for our bicep file to a resource group. So we just run the AZ deployment group create command, tell it which resource group to go to, and tell it which file to use. Then under the covers, it then actually takes that bicep file, compiles it down into the JSON equivalent, and then ships that off to the ARM for us. We used to have to do this step by hand, but the CLI does this for us now. But you can still get that JSON file just if you want to potentially debug it if there is an issue, or you want to see how it looks under the covers. You can just run that bicep build on the bicep file, and it'll spit out a JSON equivalent for you. So the next step is then it takes this JSON file, talks to the Azure Resource Manager, and then we've got more than 250 resource providers to go and ask, hey, give me this thing with these settings, and it will go ahead and do that for us. So first demo, I'm going to show you some basics of Azure Bicep. So I'm going here. I'm going to create a new file quickly. I'm going to call it storage.bicep. Now, before you can actually do anything, you have to go and install the Bicep extension in VS Code. It is very, very useful. So you just go search for Bicep. You should see there it's verified by Microsoft, and you'll be good to go. Now, what makes this extension so useful is it's got a lot of the snippets built in. So all I need to do is type in res dash, and then I can actually see a whole bunch of options already that are available for the types of resource I'd like to create. So if I go and select, we're going to storage. Here we go. Here we go. So straight away, it populates a bunch of stuff for me. I can give this a syntactic name, or a symbolic name, sorry. So there's going to be my storage. Doesn't matter what it's called. Then we can see here, might just zoom in a little bit more. There we go. So we can see here's a resource provider string and an API, or sort of date here. All right, so I just go press at, and automatically you can see here all the different versions of this storage account API that we can choose from. Okay, I'll always pick the latest, and there we go. Now that we can go and define the name of, we're going to call this net UG 20 live. There we go. You get a few names. Oh yes, storage accounts can't have uppercases in them, so I'll just do this all lowercase for now. And then we can see we've got an error here already. It's complaining. Location doesn't exist. Okay, then we go and say Australia East. Oh, for some reason I've got the weird keyboard things happening. Where's that? Let's see. Hopefully that's gone now. Yeah, there we go. Australia. Yeah, all right, Australia East. There we go. But it's still complaining. A resource location should not be hard-coded. Oh, okay. Now I know what that means, so we can just go and declare a parameter, call it location. And I think we can go and declare a string. And we can give it a default value. So here I can say Australia East. Why is it so hard to spell? All right. And then I can reuse this one here. There we go. Now it shouldn't complain. It's great. And what is really nice about this as well, with the old JSON, you had to remember a lot of the values or look at the documentation the whole time. But now we get all the cool intelligence. It already knows most of the options that are available. Here and there, you might find something that it doesn't know about yet, but the Bicep and the Azure team are hard at work at what you're on fixing that for us, so we can actually write these things a whole lot quicker. So you can see here all the SKUs that we're able to choose from. We can go ahead and pick the right one there. So that is it. That's really the basics of writing up a resource in Bicep. Like I said, there's the res, there's also a snippet, there's a whole lot of stuff in there. But what you can also do is something a little bit more complicated. I don't know. I'll go My Cosmos. Why not? So you can go Microsoft. You can see it, all the provider names are here are listed. There are so many. All right. So as long as you know which one you're looking for, you should be able to find it pretty quickly. So if we go databases, SQL servers, here we go. Oh, no, not SQL Server. I want, where is Cosmos going to be? Let's just do this. Cosmos. Is it still DocumentDB? Oh, there's DocumentDB. There you go. So we can actually go and create a DocumentDB account here. We choose the version, and then we say, show me all the required properties, and then off we go. So we can type in a bunch of stuff and get it to work. There we go. Typo. It's easy as that. Okay. So I'm just going to delete this. I don't actually want to deploy that bit. I'm going to reuse this little Bicep file that I just wrote. I'm actually going to go and deploy this out to Azure. Now I've got a deploy.ps1, a PowerShell file here that I've already created. I might just make sure everything's nice and unique. Why not? And all we need to do is to say, run this AZ deployment group create command, provide a whole bunch of parameters, and tell it which resource group you want to go to. So this is one of my inputs to this file, but giving it a default value, and storage.bicep, which is the name of that file there. And I'm doing a few other little bits. So I'm actually also outputting some values here. So let's do that. So let's put in a output, something interesting. So we'll just call it storage account name. And that's going to be a string. And so what we want to do is go my storage. So that storage object, we can inspect that and go in and say, hey, there's various properties and a bunch of stuff we can output. Just simply for demo's sake, I'm going to output the name, even though you know it's there already. But we'll see what that looks like when we go and deploy it. So I'm going to run this file here and show you what that looks like. So let me just clear that. Live. Okay. Can we make that a little bit bigger? There we go. So that should, fingers crossed, just work out of the box. All right, so it's going to go and create my resource group for me, and then it's going to go and deploy that Bicep file and then create a resource group for us. So we can go back to the file here, and we see what we would call it. So storage net UG live. Okay, so give that a second. Now if I go back to the Azure portal, and I go into this, is that the resource group name we used? Let me double check. So it's not showing up yet. Should be this one. There it is. Okay, and the storage account hasn't shown up yet, but if we can look at the deployments, we can see the portal does sometimes take a little bit of time to catch up. But if we look at the details, here's the name of that storage account that we try to provision. And it says everything's okay, cool. But just for out of interest, right? So here's the inputs that we gave it. I just have a location input, nothing special. Here's the JSON equivalent that Azure actually received to deploy that storage account. And we can see here is it's a little bit not as nice as the Bicep version. It's a bit more complicated, a lot of quotes and things around that makes it a bit hard to read. And we can also see here's an output, which is that name that we wanted to output. So on the command line, if I go back, just my little script here did that output for us as well. So which is pretty cool. So that storage account got deployed and is good to go. All right. So that is the basics of creating a Bicep file and deploying it. So nice and straight and forward. What are the limitations of Azure Bicep? Well, it is not a configuration management tool. It's literally just something to declare and provision our resources. It stops there. It doesn't go and set up the development IDEs or any sort of software that you want on a virtual machine or anything after that. It can deploy a VM for you, but after that, that's where it stops. If you need to have any sort of data or software installed or configured on a resource, Azure Bicep won't do that for you. You need to use something like Chef or Puppet or Ansible even to do that kind of stuff. Now, some of them might also be able to provision infrastructure for you, but they're very different tools, and you need to specialize in them fairly heavily. Okay. So we know now what Azure Bicep is. Let's see how it compares to some of the other options out there. So we can start by looking at, we've got Azure Bicep, Terraform, and Pulumi. So the big difference for me is the way that they manage state. Azure Bicep uses live state. So it will look at the resources that you have in your resource group or your subscription, and it'll compare that current live state with what you're trying to deploy from that Bicep file. The difference is that, say, for Terraform and Pulumi, they actually download that state and keep that locally. And before it actually does anything in Azure, it'll do a diff and work out that state difference and only deploy the smallest set of changes for you. But that state you have to manage yourself. You have to store it locally, or with one of the paid options there, they can store that remotely for you and manage it for you. Okay. Cool. Now the programming style is quite different between the Azure Bicep, Terraform, and then Pulumi. But Bicep and Terraform uses a DSL. So we've got Bicep, we've got HCL, which is the HashiCorp configuration language, and then with Pulumi, it's done imperatively. So we can actually use like C#, F#, JavaScript, TypeScript, Go, Python to do things in a lot more complicated ways, which is nice. Actually, I've used that. It's really cool. Okay, now Bicep is free, totally free. You don't pay for anything. You just pay for your Azure bill, and that's it. You get this all for nothing. Whereas with Terraform, it is free. Same as Pulumi, it is free, but they have paid offerings just for that sort of next level management of all your projects and your stacks in there. And the way that these projects are managed by themselves, Bicep and Terraform works in modules, so reusable pieces of infrastructure as code that you can deploy by themselves. You don't have to have the whole thing, or the whole set to deploy. Whereas with Pulumi, it's like a whole application or a micro project that you can use to deploy or provision your resources. When it comes to multi-cloud, Azure Bicep, as it says in the name, it's just for Azure. Terraform and Pulumi, they support multiple clouds. But if you know Azure and you use Terraform, if you don't know AWS, for instance, you might have to learn AWS. It's not going to magically just make you an expert in AWS or GCP just by using the same tool. It's the familiarity of the same tool is great, but learning the different services in each of the different cloud providers is going to be important. That's a bit of the learning curve for yourself to go through. Each of the respective companies support their product. If you use Bicep, that's from Microsoft. If you're using Terraform, it's HashiCorp. They've got a good relationship with Microsoft, but your mileage might vary on support there. Same with Pulumi. Everything's open source. It's great. You can see how it all works under the covers. It's really nice. You look at Pulumi, it actually uses Terraform under the covers as well for some things. So yeah, cool. Why not? And then this is totally subjective for me, the learning curve, because I'm very used to how Azure works and spent a long time with Azure JSON. So the learning curve was quite low for me, but Terraform and Pulumi, of course, a little bit higher, but nothing complicated there really. It's if you're into DevOps or sort of the infrastructure side of things. A lot of it that makes sense, and you should be able to get your job done fairly easily. So how to actually do Bicep the proper way? So you have to start by installing the tools. So you need the Azure CLI, or you can use PowerShell as well. And like I showed you just a little bit earlier, the VS Code extension. Now, if you don't have Bicep installed locally, 2 commands, just Bicep or AZ Bicep install and AC Bicep upgrade. So make sure you get the latest version. So it's 0.9 something at the moment, so almost at version 1. Pretty cool. And then we can actually use, this lets us use Bicep in all of our sort of DevOps pipelines, Azure DevOps pipelines, or GitHub workflows as well to get the job done. So it's pretty nice. All right, so now I want to go and show you a little bit more about what you can do in Bicep. I've shown you a real quick version of how to create a storage account, but there's a lot more to the Bicep language than what I've shown you so far. And so I've broken it down into a whole lot of basics. So like good programs, they have inputs or parameters. So these are the things that you can choose at the time of deployment, the value that should be going into your application. But you don't want to have just random stuff going in. You can actually limit the inputs into your Bicep file. So you can actually say with this allowed decorator, the values of this location parameter. So if I, for instance, wanted to run a deployment and say East US, the computer will say no, it's not allowed. All right. So, but that's quite nice. You can actually restrict this. You know, if it's not for locations, but for SKUs, for instance, you don't want to, for instance, deploy a P12 database that costs $30,000 a month, right? So you can actually limit the inputs in there. You know, that makes sense. Something really nice, we can actually add comments in our Bicep files. It was not really allowed in JSON until recently. But yeah, comments are good. And I'm quite happy when I saw that. You can do that. But what else we can do is we can use more of the decorators to enrich the inputs. So for instance, we can add a description to each of the fields. So give it a nice worded description. We can also say what the minimum and maximum lengths are. So for instance, the name of a storage account has a limitation of up to 24 characters. So you could actually, if this was a storage account input, you could limit that to 24, and you know, you don't run the risk of running the deployment and Azure going, hey, I can't have this long name, fix it and restart. So that's quite nice. And you know, for instance, limit it to, you know, you don't want to spin up more than 10 VM instances. That's what you could use it for as well. Actually, not the length, but the max value. So you can have minimum and maximum value for integers, whereas you can have minimum and max length for strings. Now, the next cool bit is that we can actually have secure inputs as well. What's nice about these secure inputs is that if anything was logged anywhere, it would actually be blotted out for you. You won't, if you have a password or some secure API key that you're putting into your Bicep file, none of that will get logged. And it will actually warn you as well if you try and use that as an output from your Bicep file. Say, hey, please don't do that because you're going to expose something that's marked secure. So it kind of makes you do the right thing. Pretty handy. All the functions that we're used to in JSON, they've all been carried over. So, you know, for instance, here, I might just zoom out just a touch. So we're actually trying to come up with a consistent naming convention for, say, a storage account. So we want to use the prefix of storage. We want to take about 6 characters of this unique hash that's made up from the resource group ID. A little bit of randomness there at the end there. So you can have storage and some random characters there that gives you the name of the storage account. It's pretty cool. So we can use these functions to make that work. You can see here, I'll quickly show you, you get intelligence and all this as well, which is really nice. Same with unique string. It'll show you all the input parameters, and same with take. So the original string input value and the number of characters to take as an integer. So excellent. You know, we can actually write programs really easily without having to look at the documentation. All the work we do is inside of our editor or our IDE. And like I've shown already, you can have some outputs, and they can actually be of any value type. So you can have string, integer, even objects. You know, if you have a complicated JSON object, you can output that as a value too. I was going to share how to create a resource, a storage account here, but I've already done that, so I can skip that one. We can even have conditionals. Now, in this sort of contrived example, I've got two input parameters, and they're both Booleans. The one is by default true, the other one by default is false. And I'll just zoom out slightly just to show you in one go. When I declare this resource my storage account, with all the resource provider ID there, I can actually do that only if I was asked to. So if I really need a storage account based on this input value, then go ahead and do all this stuff. So if someone passed in false, it's not going to actually deploy the storage account at all. It'll skip it. But if it was true, obviously, it'll go ahead and do all the things in here. Now, we could also then use the conditional operator to see, I'll zoom back in, whether or not we want a geo-replicated storage account or not. Okay, so you go enable geo-replication, question mark, and if it is true, we use the standard GRS SKU. Otherwise, we just go back to the premium local redundant storage SKU. So that's quite nice. Makes things nice and easy, and we don't have to copy and paste code and run different files and all that stuff. This is quite nice. Now, the next thing that's really important is each Bicep file is actually a module on its own as well. So just again, another storage account Bicep file down here at the bottom. It's just how we've seen already, declared a storage account, put in all the parameters and things we want. And we can actually, instead of declaring a resource, we would normally do resource, some name, and then a provider string. Instead of doing that, we can declare a module. And same with the module also gets a symbolic name, and we can reference a Bicep file. Now, the cool thing about this Bicep file is, and the Bicep language service that we're using, it can read that file on my local machine if it's there. If it's not there, you'll get the red squigglies and it'll say, of course, doesn't know what you're talking about. But it can actually read the input parameters on that. So let's do it in another way. So I delete that part there. I want to type in params, space, and it'll then automatically prompt me to fill in the required properties. So we see here, I need to give it a name. I'll just put in whatever the previous name was. Let's put that back. I'll undo now. Sorry, can't remember what it was. There we go. And because that geo-replication actually had a default value, you can press F12 and it'll navigate to that for you. So it's pretty cool. I've got a default value for that. So it's an optional value. It's not required anymore. So we can see there, and we can then say true, false, whatever we want. And everything's happy. So, and again, the module can have an output, and we can read that output like this. So module's got a name, obviously, and then it's got outputs, and then it'll read that original Bicep file, see what's outputs of that, and let us reuse that. So really, really nice. So just makes it easy for us to string things together. Now we're getting a little bit more complicated. Loops. We can actually do iterations based on just a simple count, and the way that works. Whether it's for a module or a resource, that's fine. It works for both of them. We'll sort of specify it like this. So for I in a range X to Y, so from 0 to storage count. And then it'll actually loop through, and we can use this value I to indicate the instance number of a storage account, or the deployment, and then the storage account name, which is quite nice. In fact, I just realized that won't work because you can't have hyphens in the storage account name, so I'll save that. Bug fix for next time. So this will just loop through. If that was 2, it'll go 0, 1, because arrays, obviously, starting at 0. And easy. But we have another option of how to do looping. We can actually loop through an array of elements. So I have a list of names here. So instead of instance counts, I've got names. So I can deploy the storage account that will have one of these storage account names simply by looping over the names with the syntax. So for name in array. And I can actually use that name as part of the deployment or the storage account name. Quite handy. But wait, there's more. We can actually combine them. So we can have an array of strings or an array of objects. And when we want to loop over that, let's zoom out hang on, I might just, there you go, a bit more space. Zoom a little bit. There we go. So we can combine that notation from earlier, and we can actually get both the value or the object and the indexer value. So config and I. And we can actually see here, so I've got config.suffix, config.skew that we can actually use to read this object from that array and use that as inputs into the storage account module. Quite handy. So even, for instance, if you're specifying firewall settings or network settings, large objects, you can loop through them if you have multiple instances, and just simplifies things quite a lot. All right, and that's it. So there's our 3 options for doing loops, which is really cool. The next thing is scoping. Now, this is kind of not something that I've used a lot until a little while ago. Now I use it a lot. It's very handy. And the reason is when you create a deployment, you normally say which resource group you deploy it to. All right, so just like that. I'll zoom in for you to see. And then, I'm reusing that storage account. It's going to go into this resource group, and straightforward. We've seen that already. But what if we actually wanted to deploy a storage account into a different resource group? For whatever reason, storage accounts have to go into a dedicated resource group. We can do that. We can actually have, say, for instance, no matter how we do it, but one of the ways is we can have an input here that we have the name of the resource group as an input parameter. We use that module, and we specify scope and resource group name. So you can see this is missing from the first example. So we can actually override the default scope to point to another resource group. So that's pretty cool. So I can deploy to this resource group and this other resource group in the same file. Now, you could do that with ARM and JSON, but it's a lot of work. You have to do nested templates, and you go cross-eyed pretty quickly because there's a lot of JSON and things and repeated code that you get lost pretty quickly. This is way easier. You can even go into a different subscription. So this resource group function over here for scoping, you can give it a ID for a subscription, and then again another resource group name. Pretty cool. So you can actually have a gigantic Bicep file that deploys across resource groups and subscriptions, for setting up someone, for instance, with the cloud adoption framework. They do this kind of thing a lot with those templates. So you can deploy a whole lot of stuff in different places all at once. It's pretty cool. Now, you can also deploy things to, like I said, by default, the scope is to resource groups, but you can change that to, by default, go to subscriptions. You can deploy subscription level resources like resource groups. And then again, at tenants, you can change the scope to tenant and also deploy some management groups and other things into that. So a bit more advanced. Don't use that too often, but you can. So that's pretty cool. Now, with the Bicep files, you can use when you run a deployment, I'll show you just this bit of code again. If you're familiar with this, you can actually pass in a parameters.json file, but it's still JSON. You can't pass in a Bicep file just yet for some reason. And you have to do a little bit of cheating in a way. But it's in the official docs, so it's all good. They allow it. So instead of passing in a JSON file, you can have a parameters or a config map or config set Bicep file, where for the different environments, you have different settings. So for instance, different SKUs for production versus staging versus dev, right? So you can see I have an environment name as the input, and it's restricted to the ones that I support. And I define a big object here with the initial key being the environment name. And then say for a web app, I have a SKU and the name for that SKU and the capacity or the scalar instances, and do that for all the other ones, just going lower and lower, cheaper and cheaper resources. And then when I deploy my app service plan, I can actually index into that config map with my environment name and then get all the different properties. But now, just unfortunately, not sometimes, but currently, indexing or IntelliSense doesn't quite dig into these objects just yet. Hopefully, one day soon, that will be sorted and will actually be a lot nicer than it is right now. But not too hard. You can still sort of easily work it out and have your values pumped into a new resource or a module. It's kind of cool. All right. So that's the basics of how to Bicep. Yeah, you can use all those programming constructs to create resources or even conditionally create them. Yeah, you can have functions to define conventions for naming and all sorts of stuff, and do whatever maths and things you need. It's all there, and it's pretty handy. So much more closer to a nicer programming language than trying to shoehorn programming concepts into a data format like JSON. Now, let's see. I actually want to go back to the demo, the code slides first. And I should have shown you this a little bit earlier. But what you can do is all the AZ commands that we had before, we can do all of that in our Azure DevOps pipelines or GitHub workflows, okay? And the example I've got here is, I've got a number of jobs. So I can actually run a linting process. So there's a linter for Bicep. I can do some code quality checks. The things that will give me little squigglies to say, don't use hard-coded locations or don't use hard-coded URLs. There's a lot of rules. I'll show you where you can define those rules. But you can actually run that linting over your Bicep file by using the AZ Bicep build command. And if that fails, if it pumps out any errors, then it'll fail your GitHub workflow, which is quite nice. We can then go ahead and, with all this code, we can check out our code. We can then log into Azure with our credentials, make sure we can create the resource group we need, and then we can run a validation on our Bicep file. So it'll actually look at the shape of the file, look if we're trying to create resource types that exist, and if we're trying to do something that's just not compatible with the ARM schema, it'll fail this. It'll, again, won't just try and run something without knowing that it should succeed. Then the next step, what we can do is we can actually run this thing called what if. And that is, again, instead of what we've had before was validate, we can run what if. Now, what if is great for checking the state of what we're deploying or trying to deploy versus what is currently in Azure. So I'll run this in a minute. I'll show you what that looks like. But essentially, it does a diff, and it'll tell you you're trying to add or remove a number of resources, or trying to modify an existing resource. And it shows that to you there. You can actually use this step as a sort of a gated check, just so someone can go and make sure and see that the what if is not going to drop the production database. If they go, oh, hey, there's some resources being added or removed that is not approved, they can fail that process. So you can't actually go ahead and deploy those, provision those resource changes. It's not 100% accurate yet. It's still working on it when it comes from the Bicep files. Reason is just the way that the nested templates and things work to reference resources in other resource groups and subscriptions. So there's a few little kinks there that sometimes are not very accurate, but it's getting a whole lot better. In fact, it hasn't happened for a while, though I think about it. But in the earlier versions of Bicep, this did sort of give me a few headaches. But yeah, it's been pretty good lately. This one is just more about building a function app, so it's not too relevant for right now. But when I then go later on and deploy my infrastructure, same bunch of things here. Let me just make it a little bit bigger or fit it all in. Okay, so here's my deploy infra job. I've got some outputs here. So in my workflow, I want to reuse some of the outputs from my Bicep file, and I'll show you how that works. Now, a little bit more complicated than before, but that's my fault because I want to actually go and run this deployment group create command. You've seen we had validate and what if before. Now we've got create, and I've got all the input files there. There's my Bicep file, and here's a bit of magic here to pull out just the outputs of the deployment. I don't want to, there's a whole lot of JSON that gets outputted from the whole deployment. I'm interested in just the output values, which I store in this object here, and do a little bit of magic here to write out or to set these GitHub environment variables or output variables from the values returned from the Bicep file. All right, Try and say that fast 3 times. But yeah, I'm trying to get the name of the function app, the storage account, and the storage container name as well. So I want to reuse that somewhere else in my app. A thing down here. Yeah, there's a whole bunch of options here for reusing that. So a bit of a over-the-top example for how to deploy a Azure Function app with a whole bunch of things like RBAC and things turned on. So it's not very restricted for who's got access and who can do what to it. But just as an example, you can run all the Bicep commands in a GitHub workflow or an Azure DevOps pipeline. So very handy. Cool. So just to recap, we can have the Bicep linting. So the AZ Bicep build, it'll do the code quality check for us, and it'll fail if something's gone wrong. We can validate our Bicep file as well to make sure everything's in the right shape. And we can then run what if to just see what is actually changing. We're adding, removing, or just modifying resources. Yes, and I forgot to point out, we're sort of needing the previous stages to succeed before you're running these stages. We can actually build up our whole DevOps pipeline with those dependencies. Then finally, go ahead and deploy or provision our Bicep file by using the deploy group create commands. And when you're running in GitHub, your workflow should pump out something like this. So we can see in parallel, I'm building the application, I'm checking the best practices, or running the Bicep linting command, and I'm also validating the Bicep resources at the same time. Once that's all done, I do the what if and go ahead and deploy the infrastructure, and then deploying the actual function app itself as well. So all green ticks, nice and simple process. And you can actually go to my GitHub links later, and you can see how this is running in action. You just go ahead and run the action file. Why not? Cool. So, all right. Now, very important, I want to check out a thing called module registries. What are they? So there's 2 flavors in Bicep currently, private registries and a public registry. The private registries for us, we can go and take some of our Bicep code and store them in an Azure Container Registry. Same place where you would store your Docker images. It's just using the OCI or the Open Container Image format. You can store all sorts of stuff in there, actually. Why not store Bicep modules? And because it actually is easier then to read them out of there as well. Now, the reason we want to do this is we can actually create a bunch of modules that even reuse other modules. So we have our complicated architectures for a particular full stack application, or a network configuration, or a landing zone for a client, right? So we can have all of that saved in our registry, and we can even tag them with versions, and then we can just have a very simple orchestrated template or Bicep template file that just calls out to our registry with the basic inputs that we need, and it'll just deploy that huge architecture for us into the cloud, which is quite nice. It simplifies things a lot. The public registry, I'll open that up and show you. Now, this is one hosted by Microsoft. It's on GitHub. It's only been around for a little while, so it's not a lot on there yet. But you can see here, they're actually putting up container apps, environments. There's a sort of game development VM, which is pretty cool. Actually, should check that out. And there's a few other ones there, right? Some basic Hello Worlds, virtual networks, etc. So this will be great because all you basically need to do is a few basic inputs. You got a whole custom infrastructure that they've put together for you, and we can actually go and contribute to this ourselves as well. Just provide your Bicep files. It'll go through their sort of quality process, and it'll get merged into this repository. So there's you can see here. So you go to the Bicep registry modules. So that's pretty cool. But it's only been around for a little while, and so it's a bit limited. But watch the space. It's going to be pretty cool. Okay. Now, I want to share a demo for how to use module registries. So back to VS Code, we can go in here. I've got a folder called the registries. Now, I've already gone and deployed an Azure Container Registry where I want to go and store a bunch of my Bicep files. And just to show you what I mean is I've got a bunch of Bicep files here. One for a Key Vault, So just a basic setup for Key Vault. I'm also just for demo purposes putting a API key into Key Vault directly via Bicep. I'm setting up some databases here, so SQL Server and a database, with a randomly generated passwords, and I've got the performance tier as inputs, and I'm generating the connection string in the Bicep file. Sorry, and I'm actually reaching out to a Key Vault that I expect to be there, and adding a secret into that Key Vault. So my function app or my ASP.NET app can interact with Key Vault and get that connection string for me. So I don't actually have to store it in app settings, doing things a little bit more securely. Again, storage account, store images or whatever, documents in there. Again, storing the connection string in Key Vault, outputting a bunch of values. Then I've got a web app. I'll show you here all the inputs. Some limited, well, these are all the options available. So, for all the different performance tiers for the server, setting up log analytics with app insights, the app service plan, the web app itself, some basic settings, adding a Key Vault policy so that the app can actually read secrets from the Key Vault, and just setting up some role-based access here for the storage account and for app insights. Cool. Now, there's a lot of templates here I showed you, but I put them together with this one overall template. It's called Full Stack Web App Template. And it's just got a few basic inputs. So I'm making sure that I'm deploying to a resource group, giving it a name for my project. I'm also providing an environment name. So I want to tag my resources with the environment name. So like dev, test, staging, etc. I also include the deployment date. So I actually use that as part of the tags. So when I deploy a resource, you can add tags for billing purposes or other sort of visibility accounting purposes. You can also say, if you wanted to input who deployed these, so and which branch they were deployed from, and all that kind of stuff. So it's very useful. Yeah, a few more input parameters. But then I'm actually going here and referencing my Key Vault module. I'm not referencing the Key Vault module via the Bicep file. I'm actually referencing it via the this little extra notation here via the container registry. So here, BR stands for the Bicep registry, and then I've actually set up an alias so that there's a little bit of a shorter syntax. And I'll show you how to do that in a second. So I've got an alias for NetUG 2022, my Key Vault resource, and then also the version. So I can actually version my modules. Okay. Now, I've done that for all the other ones. So I also want a storage account, put in all the basic inputs for that storage account. I'm reusing the outputs from Key Vault into the storage account. Got the database, got the web app, and all the performance options I want there, and the names of the blob container that I want to attach or put attachments into, etc. Okay, cool. So there's a whole bunch of stuff here. Now, I'm going to highlight this bit here. So, like I said, we can reference a module from the Bicep registry, and we do that via our Bicep config file. So we can actually set up the module aliases for Bicep registry. You can also do for template specs. I'm not covering that in this talk, but you can do the same thing for template specs. And so here's the name of my alias that I want to use. And I can actually say the full name of the registry in Azure. So I've already got this one set up, right? So if I go to the Azure portal, go to resource groups, I know I put it in here. Here it is. ACR Net UG 2022. Okay. Now, I just want to show you something else first. So if I go into here, I have just a basic PowerShell file just to publish my modules to the registry. So a little bit of PowerShell magic, but essentially I want to go and use the AZ Bicep publish command and give it my file, tell it which registry to go to. So that should be the same name. Double check that quickly. ACR Net UG 2022. ACR, yeah, okay, same name. So BR, the name, and then the full path of where it should go. and I'm also giving it a tag, so the version tag. All right, so I want to run this, and here we go. I remember the name again. Hopefully it's in here. There we go. And so I want to use the version 1.2 tag. So this is going to take a little while. I'm going to take the Bicep files from my local machine, upload them to the container registry, and once they're there, we can inspect the registry to see what's there. And you'll also notice that the Bicep linting or Bicep config file, it'll show you if you've got any warnings in here as well, because essentially it's still building the Bicep file into JSON for you, just making a code quality check. So for instance here, I've got a warning. So it's not an error, it's a warning. And in that Bicep config file, we can actually say what we want to have as errors and warnings. I've only got a limited set here, but in the Bicep documentation, there's quite a lot more options you can add in. IntelliSense, unfortunately, doesn't work for those rules in here. There's nothing that's going to give you a hint of what you can do, but you have to go and check the docs. But for instance, I've got things in here like don't have hard-coded environment URLs, or don't have any unused parameters in there, or variables, so it's like different, prefer string interpolation instead of concatenation, etc. All right, so we can actually sort of have in our rules of what we want. You even turn them all off if we want to, be a cowboy. All right, so in a nutshell, I've got a module alias to my Bicep registry that I can use to reference modules in a shorter way. So I'm referencing version 1.2, and what have we got? Yeah, so doing that for all of them, and we've gone and published all of them to our container registry. And if we go to the portal into our container registry, look at repositories, you see here they all are, which is pretty nice. So go away. Okay. Now, if you click on it, you can see the past versions and the dates and when they were all there. Trying to dig deeper into that as well. Yeah, you get a bit of information, but you don't really get a lot more than that. So you don't actually get to see the actual code behind it, which is annoying. Maybe one day that will be a thing that we can do to sort of have a deep inspection of the resources in there. But in VS Code, this works already, right? In some way. So that key vault file module in the Bicep registry, VS Code would actually pull that down from the Bicep registry. As long as you've done AZ login, it'll cache it locally, and that Bicep language service will kick in, and it'll actually be able to tell us, hey, here's all your input parameters. Even though it was not really on your local machine, it's from the container registry, you can still do all your nice things with it, and it just works. If your computer can't reach that registry, this will be under red squiggly. So if I just put in a dodgy character there, you see here, it won't be able to get to that module. Cool. Now, moment of truth. If we go and do the next thing, so I actually want to deploy this full stack web application. Now, I'm jumping around a little bit. Here is the full stack application. Like I said, it's got referencing all the modules, but it still has a few inputs. I can simplify things even further. So I can use an overall orchestrator template, and so I've wrapped up that full stack app, and it's also uploaded to the container registry. Now I can reference that one. Here's the full reference. I'm not using the alias. You can see it's quite long. Okay, but I'm also, let me just take all these out. You can see all the properties that I need are available through IntelliSense. So I'm just going to put them back, and all I need to do is to deploy just this one. This one Bicep file. Okay, so in here, I've already got it. So I'm going to deploy web app, and everything should have a default value. So fingers crossed, this all should just work. It will take a couple of minutes. All right. So what we can do to see if that's actually doing something, we can go to our resource groups, and I forget which resource group we're using. NetUG 2022. Okay, and I've zoomed in way too much. Let's fix that. I can look at the deployments tab here, and we can see that, is that the time now? I think so. Yeah, so it's already running the deployment for some of these things. Actually, is that the right resource group? Let's double check that. Yeah, here's the right one, sorry. So we can go into our deployments here. You can see things actually busy being deployed. Something's already succeeded. Fingers crossed, should all work, but it will take a little while. So let's just go back to the slides and we'll come back to this. All right, let's go back. Now, I spoke about how we can use the module registries. We can develop our Bicep templates. We can publish them to the container registry, okay? And we can actually do a lot of this in a good DevOps process as well. So by looking at this process, for instance, we can commit our code. We can actually run a validation on those resources. We can, mock deploy them to Azure, make sure that they're in the right shape. We can then even run a smoke test. So for instance, on a storage account, if that storage account had public access turned off, so we can actually write a test to see if we can access something on that storage account, and fail it if I disabled public storage, but we can get to it, that's a failure, right? Or the other way around. Same with a web app. We can actually deploy the web app and inspect it for a variety of things that we would think will pass or fail that test based on whatever our template requires. And if that's the case, you fail that build, and you ask the developer to go ahead and fix it again. But if everything's passed, it's all good, we can merge that into our repository, and then we can publish that module to our registry. So we want to make sure that these modules that are in our Bicep registry, they're always green, they're always passing, they're always working, and that we can just reuse them as much as we need. Okay, so if we go back to the demo, it's still running. Let's see here. If we go refresh, everything's green, which is great. Let's see. Done. Beautiful. Everything ran. No errors, which is really, really nice to see. So we can see here, here's all the deployment, the individual deployments. So if we go back and see this first one, look at the details here. So that goes and deploys the web app. So we'll just dig down a little bit deeper. You can see here, I'm not sure if I can close that window, but this is all the nested templates. If we actually inspect this JSON that's here, I did not write any of this. This is what was generated from me. There's so much more code in here than what I wrote in the Bicep file, right? So it's actually deploying these different resources with nested deployments, and it's just making life a whole lot easier for me. So I'll just dig in a little bit further. Let's say, what else is there? Oh, these goes directly into the individual ones. So if I go back to the previous one, how do I do that? Go back. I lost my back button on the screen. There it is. Yeah, this one in particular is going to be, it's the same one. Sorry, clicked on the wrong thing. So if we go back to our resource group, so it was the live one here. No, the other live one. And now we should be able to see all of our resources here. Where's that? Collapse that. So here's everything that we deployed from that one Bicep file. So we've got the SQL servers, we've got App Insights, we've got our Key Vault. We actually can go in there, and if I might not have access, so just quickly do this, add myself to be able to see everything. Why not? There we go. Choose that name, select, add. Make sure you click the save button, because I don't know how many times I forgot to do that. I had to redo it. So here we can see is the connection strings that was added from the Bicep, in the Bicep file, into Key Vault for us. So here's the storage account connection string, the database connection string, and my secret API key. Pretty cool. All right, all the other things are there. Here's my app service. Even that one, I've gone and set up some basic app configuration. And here we go. Here's the URL for that Key Vault that we had there. So everything just works. All the things that we did for outputting values from a module and wiring that into the inputs of the next module, that all works. It's great. Cool. All right. So Finally, the pros and cons of Azure Bicep. There's no managed state. I don't have to do anything. Azure Bicep does it for me. That live state of what's currently in Azure versus what I'm trying to deploy, and the what if command doing the diff for me, that's really, really nice. It's a much simpler syntax. You save a lot of keystrokes, and why not? You don't want to do things unnecessarily. The code reuse is amazing, especially because of the module registries or the Bicep registries. You don't have to copy and paste things. You can save it in one place and literally just reuse it. The scoping is cool because now I can actually make even more complicated deployments, much more useful. And we can also prevent the output of secure values. This was a bit of a risk in the JSON. You can actually print your passwords and your keys and things that you weren't supposed to do, whereas Bicep can warn you when you do that. You probably can still turn it off if you really wanted to, but you shouldn't. Already mentioned the module registries. They're really, really cool, really useful. And the day zero support from Microsoft. So this is the default option now. As soon as a new resource or new service in Azure becomes available, Bicep supports it straight away. Really awesome. So just the way it works, it reads directly off the ARM schema, and basically lets us just deploy those resources on day one. If you really, really wanted to, you can still see what the JSON equivalent is like. It's nice just to inspect and make sure everything's still good. There has been a couple of glitches, but not for a while, but there's still an option there to go and have a look. Like I mentioned, live state, one of the cons, is not fully accurate. It still gives some false readings now and then, but definitely has been improving a lot. The visualizer can't deal with modules. I should actually show you that. So I forgot to show you that little beauty. If we look at this full stack web app Bicep that we have, it's made up completely out of references to modules. Now what we could do is actually use the Bicep visualizer. You can click that option there, or it is a little option here in the toolbar up here. If you click that, if I just collapse things a little bit, it doesn't quite show me exactly what I wanted to see. It shows that they're modules, but not really what's inside of them. So I know, for instance, this web app module has a lot more stuff in it, but I can't see what's in there. But I know I can go to that module, which is quite nice. To show you what I'm expecting to see, if I go to web app here and close that one and open up another visualizer, I expect to see, just make it a bit bigger. Oh, there you go. Here we go. So here's more of a realistic view. It shows me the true resources that I'm actually deploying in that Bicep file. So hopefully one day the visualizer can actually expand those little module folders into this, and then you can sort of dig deeper into what you're trying to deploy visually. It's quite nice. Okay, so a bit of a con right now, but still a great thing to use. It makes it easy to sort of reason about what's going on, how things are stitched together. There are no user-defined functions, not yet. In JSON, you could actually define your own functions. So for instance, to generate a particular name or some sort of calculation that you're trying to do, you can do that in JSON. They haven't brought that into Bicep yet. I think they're trying to keep the sort of more declarative, deterministic nature of the templates. So they're working hard on it. There is a GitHub issue for it. It's been around for quite a while, but I haven't really missed it yet, to be honest. Even though I said it's a con, I just really haven't missed it. If I want to have some reusable logic that I've created, I can actually put it into a file, which a module, and I reference it as a module, and just read the outputs from it. So that still works in a roundabout way. But I think also if you had UDFs, you'll start creating dependencies between your modules, and that's probably not a nice thing. So instead of just shipping one module, you'll have to find all the dependent ones and ship them. But because without them, your deployment will fail. So that's an interesting one. So we'll see how that evolves and what we get out of it. No resource provider aliases. So this is not really a major con, but what that means is if we look at our Bicep files, especially here, here's a good example straight away. These resource provider strings they could be quite long. And there'd be a nice way if we could, just like how we gave aliases to our Bicep registry, container registries, it would be nice if we could do the same thing for resource providers. So if I wanted to have it just as an alias, for instance, just storage accounts, I didn't want all that extra stuff. That would be a bit nicer, a bit shorter. But currently it doesn't exist, but hopefully one day it does. Parameters file is still in JSON. Yes, I already explained a little workaround to that. You can use a Bicep file, but it's not quite the same input as the traditional parameter file, but there is a workaround. And listing keys are inconsistent. The way that you get primary keys or secondary keys from different resources, they're a little bit different. They're all sort of specific per service in Azure. So it would be nice if they found a way to make this a little bit easier. Sometimes the property is called primary key, and sometimes it's value with an index of 0. Yeah, it gets a little bit weird sometimes. You have to go back to the docs for each of those services to figure out how do I get the keys out of it. Now, here's a whole bunch of links you can go and check out. I've got a GitHub repository with all the code you've seen there, all the samples that are there for you to use. The Bicep project on GitHub is really useful. There's a lot of information in there. The Microsoft Docs, literally everything you need. MS Learn, it has some good modules that you can go through and learn Bicep from scratch, and all the way to deploying Kubernetes clusters. Even I think it's in there. The Azure Architecture Center, they're starting to add Bicep examples in there. So if you look at some of their sample architectures, you'll be able to get the links to the code. I'm thinking one day soon they will actually use that public registry. So those architectures might go and live in that public registry, and we can just reuse them as we see them on the screen. There are some quick start templates repo, and the Bicep playground. So if you don't want to do anything other than just play around with Bicep quickly, it's as far as I can tell, it's a Blazor app, and it'll let you basically play around with some of the basic examples of setting up VMs and storage accounts. But you can also bring a JSON file, and the CLI can actually take that JSON file and convert it into a Bicep file for you, which is quite nice. So you can actually modernize your, I don't know, just pick some random example there, but you can see here's the JSON version and here's the Bicep version. And so you can go ahead and compare them and play around. So you don't have to install anything on your computer. You just do it all through the browser. I don't know which example I clicked. Just randomly clicked one. Container apps. Cool. One of the nice new services you can play around with. So if you go and click on the decompile, you can upload your own JSON file, see what it does. All right. But in summary, for me, Bicep, it definitely complies to the KISS principles. It's KISS by design. Everything is super easy, super simple, nothing too complicated. The improved programming syntax is nice. It's not just shoehorning stuff into a data format. It's super cool. The code reusability saves you a lot of time. It's super valuable, all because of the great modular registries. Now, there is definitely more features coming. We're not even at version 1 yet for Bicep, and who knows what's after that. But most importantly, writing infrastructure as code is fun again. Thank you, everybody. Thank you very much.